In this video, we're going to talk about the domain and range of graphs, how to express them algebraically, and also how to identify from a graph whether the domain is discrete or continuous, because that will influence how we express the domain and range symbolically. In the first problem, in the first graph, it's called cookies at a presentation. The context of the problem is that there's presentations being made throughout the day, and at each presentation, a certain number of cookies were given to the people who are listening to the presentation. So that is why, as the number of presentations increases, the amount of cookies left decreases. Now, you'll notice that the points are disconnected. When the points are disconnected, that means that the domain of the function, and it is a function, we'll talk about that in a second, but the domain of the function is discrete, disconnected. So this makes sense in the context of the problem because the person is only giving out a certain number of cookies once for each presentation. The cookies are not being continuously distributed throughout each presentation in between the presentations. It's only once per presentation. So the points would be disconnected. And the types of numbers that you see down here, these are whole numbers. Or we could also call them non-negative integers because they don't include negatives because you wouldn't have a negative number of presentations. And they don't include decimals or fractions because, again, we're only giving cookies out for each whole presentation. We're not going to give cookies out, for a half of a presentation or a third of a presentation. And then also, this is a function and it's a relation. They are all relations because it passes the vertical line test. So if you draw vertical lines through the points on this graph, you'll notice that each vertical line touches the graph at only 1 point, no more than 1 point. Okay, so I'm going to highlight over here that this is a function and a relation, and the domain is discrete. So because the domain is discrete, when we express it symbolically, we're just making a list. So when you use a list, you want to enclose the list in braces, which are the curly brackets. And the order doesn't matter when you're creating a list. Usually I like to go in order just so I don't skip anything, but the order doesn't matter. So what you would do is you would go to each point on the graph and just trace it down to the x-axis to see what x value is being used. So for the first point, it's 0. For the second point, it's 1. Okay, etc. And then we go all the way up until 6. Now, in this problem, it just so happens that all of the numbers are being used through 6. That might not be the case. Okay, it could be scattered. There could be negatives if it was a different type of a problem. But that's how you would go about finding the domain when the points are disconnected. And then for the range, what you're doing is you're tracing to the y-axis. So again, the order doesn't matter, but I usually start at the lowest point. Okay, so notice that that's 0. Okay, so in other words, after 6 presentations are made, there are 0 cookies left. So that makes sense. Okay, then if you go up here, we're going to assume this is 30 because it's halfway between the 20 and the 40. So after 5 presentations are made, there are 30 cookies left, etc. Also, you'll notice that there's a constant rate of change here because 30 cookies were distributed at every presentation, but that doesn't have to be the case if you're presented with a graph like this. It could be anything. We're not just looking at linear functions, okay? All right, so I'm just going to continue here. So then it was 90, and then it's 120, 150, and 180. Okay. All right, so that's it. So that's what you do when the domain is discrete. And if the domain is discrete, the range always follows suit. So then the range would be discrete as well. Okay, in the next problem, this is not a contextualized problem, but it's a good one, so we're going to go through it. So first of all, you do see the points are disconnected, so the domain is going to be discrete. But this is not a function, because if you notice, if you draw a vertical line through x equals -3, notice how it touches the graph at more than one point. It touches it 3 times. So that means that the same x value of -3 has multiple y values associated with it. That's not a function. It doesn't pass the vertical line test, and it means that there are multiple y's for a single x. So this is only going to be a relation. Okay. But nevertheless, we're still going to express the domain and range using a list, just like we did for the previous one. So if you notice for the domain, all 3 of these points all have an x value of -3. Because if you trace to the x-axis, they all are associated with an x of -3. So what you do is you make the braces, but you just put -3. There's nothing else. Okay, now for the range, we have to go to the y-axis. Now there are 3 different points at 3 different heights, so to speak, so there are going to be 3 different y values. Okay, so for the lowest one, the y is -4, comma, then we go to 0, and then 4. Again, this one has a pattern as well. It doesn't have to be the case. It just happens to be in this case, but it doesn't have to be. Okay, so those are 2 examples of graphs with discrete, disconnected points. So now we're going to shift into continuous. So as you can see from this graph, the points are connected. Now, you don't see any endpoints, but just because you don't see them, it doesn't mean that they're not there. So because there's no arrows, you can just assume that there is a closed circle here, and there's a closed circle here. So if you don't see an open circle and there's no arrow, it's just an endpoint. It's a closed circle at the end. Okay, if you perform the vertical line test, this is going to pass. So this is a function. Basically, any line that's not vertical is going to be a function. So as you can see, the one before it, that's a linear pattern of a vertical line. So it's not going to be a function. But this is good. This is a function and it's a relation. And the points are connected, so the domain is continuous. Now, I'll just explain a little bit since this is real world. In this problem, as time goes on in hours, the amount of fuel left in the gas tank is decreasing. That's why the points are decreasing. But time is continuous. So again, you were looking at the x-axis because it's domain. So time is continuous. The truck is being continuously driven. I mean, maybe not for 20 straight hours, but in general. Okay, so over time, the fuel is continuously decreasing. So that's why you don't see separate points, it's just connected. Now, when the points are connected, when the domain is continuous, you can't list the domain and range because there's an infinite number of values that make up the domain and range. So you have to use either an inequality or an interval. So we will do both of them, okay? So for the domain, so remember, it's all the x values. So what you want to do is you want to go to the leftmost point on the graph. Well, that would be right here. That's the leftmost point. Trace down to the x-axis. Okay, so that's 0. So what that means is when time equals 0, that means it's like the right before he starts driving, or like right when he turns on the car. Like it's at the very beginning of the problem. Okay, so 0 is our starting point. It's going to be a closed circle because it's not open, there's no arrow. And then the point furthest to the right is right here. So he must have been driving for 20 hours. So it's going from 0 to 20. So it's essentially like if you had a number line that looked like that, it's going from 0 to 20, inclusive, including the endpoints and everything in between. So one way to write that is to do a hard bracket because the points are included, 0, 20. That's interval notation. Or you can write an inequality. So with an inequality, because this has a start value and an end value, it's going to be one of those sandwich inequalities. So we would put the 0 first. We put the variable in the middle. So the variable is x. The h here just means hours. That's not really the variable. And then we put the maximum, which is 20. And then because 0 is smaller than 20, we have to use less than signs. And because the points are closed or included, we're going to do the equal to. Okay, so now for you, if you have to write the domain and range, this is probably easier because you don't have to worry about what variable to use and you don't have to worry about the inequality symbols. However, if it's a multiple choice question, you'll have to be able to recognize this as also correct. Okay, so now let's do the range. So for the range, I'll just use a different color so you can see it better. So for the range, we're going low to high. So you go to the lowest point, which is right here. Now, it says 20, but the 20 is the x value. So just like we did before, now we're going to trace to the y-axis. So actually, the lowest value is 0. So that means that there was 0 gallons of fuel in the tank after 20 hours. Okay, so this is 0. And then we say, well, how high can I go? Okay, so this is the highest point right here. That's 200 gallons. So there must have been a low of 0 and a high of 200 gallons in the tank. Okay, so then that's our range from 0 to 200. So again, put the smaller number first, put the larger number second, and then you're using hard brackets because both values are included. And then if you wanted to write it as an inequality, it's going to be 0, y in the middle, because y is your variable, and 200 is the largest, and then less than or equal to, because it's less than because the 0 is smaller than 200, and it's equal to because the endpoints are included. Okay. So just as an aside, looking at this domain, so we said it's continuous. The types of numbers here, they are not just integers. They're really all the real numbers between 0 and 20. So if you were asked to describe the types of numbers in the domain, it would be, it wouldn't be all real, sorry, let me take that back. It would be the non-negative real numbers, or another good description would be non-negative rationals, okay, because that would include like half, fourth, third, like all the different fractions, and then like the terminating or repeating decimals. But again, it doesn't include the negatives. But it wouldn't just be whole numbers. It wouldn't just be integers because the in-between values are included. Okay. So let's do another example. Now this example is also continuous, but it's not real world. Now this is it's not linear. It's made up of linear pieces, but it's not linear, but we can still do it. We know how to do it. We can use our understanding to, we could apply our understanding to this. So first thing, it is a function. If you do the vertical line test, it will pass. Also, you'll notice that it's labeled f of x, and that's function notation. So function notation is only used if something is a function. Okay. So it's a function and it's a relation, but the points are connected. So the domain is continuous, and then the range follows suit. So again, because the domain is continuous, we can't list the domain and range. We have to use an interval or an inequality. So we'll do both. Okay. So we're going to start with the domain. We're going to go as far to the left as possible. Well, the furthest point to the left is right here. Be careful, the point, you're not using the 15. The 15 is the y value of the point. So trace it down to the x-axis. Okay, so the smallest x value is 0. And it's not always going to be, it happens to be for these last few problems. Okay, so I'm going to just put like a little open circle here. And then this point here is the furthest one to the right. So if we trace it to the x-axis, you'll notice the x-axis is going by ones. So this is just 12. And that was a closed circle. Okay, so this is your domain right here. Okay, again, all the in-between numbers are included. So integers, whole numbers, they don't cut it. You would have to describe this domain using non-negative rationals or non-negative reals. Okay, so using interval notation, it's going to be 0, comma 12. Now the 0, remember, had an open circle, so we use the soft bracket. The 12 has a closed circle, so we're going to use a hard bracket. So be careful of that. Okay, and then if you want to write it as an inequality, again, it's going to be a sandwich since it has a smallest number and a largest. So it's 0, x in the middle, 12 on the right. They're both going to be less than because 0 is smaller than 12 and they have to face the same direction. But the 0 has an open circle, so you don't put the equal to under that inequality symbol. The 12 is closed, so that one does get the extra ink. Remember when the circle is filled in, there's like extra ink. You can think of it like that, so you put your equal to. Okay, for the range, we're going low to high. So now we're going back to this point. This is our lowest point in addition to being the leftmost point. So the y value of this point is 15. Okay. The highest point is the same as the one on the right. It's not always going to be, but it happens to be. So if I trace this over to the y-axis, oops, it's 45. Okay, so that's closed, and it's 45. So it's everything from, oops, 15, not 0, 15 to 45. Okay, 15 to 45. You don't have to annotate it like this. I just like to do it because I feel like it separates the x and the y a little bit more. Okay, so we're going from a low of 15 to a high of 45. And you have to be careful because just because the first number here had a soft bracket doesn't mean there's a soft bracket here. There is for this one. But sometimes if the graph was going down, sometimes like that can be switched, like the soft versus hard if there's one of each. So you have to really look at it. So the 15, the circle was open. Oops. So that's soft. And the 45, the circle was closed. Okay, and then with the inequality, it's 15. Y is the variable, and it's going to 45. It's less than. And then the 45 has a closed circle, so that one is equal to. Okay. And I used Y because it says Y here. If it said f of x here, I would use f of x. In class, we did one where it was height of a tree and it was labeled h of t. And then this was t. You have to use whatever variables are provided. So try to look at the graph and try to remember to use the appropriate variables. Again, that's why sometimes it is easier just to do the interval, because then you don't have to worry. Okay, next problem. So this is we're talking about a bush that was planted, so similar to the problem that we did in class where there was a tree that was planted. However, that one had an end point, this one has an arrow. So this is a little different than the other ones that we did so far because it's the first one that has an arrow, so we have to treat it a little bit differently. Okay, as far as whether it's a function or not, it is a function. Again, it's linear, it's not vertical, it's going to pass the vertical line test. Okay, so it's a function and it's a relation. It's connected, so the domain is continuous. Now, if we think about that, again, it's time. Time is going to be continuous. But also think about the actual, what's going on in the problem. The bush is growing over time. The bush grows continuously. It's not only growing one day every year and then stopping. It's continuously growing. So you have to your domain is going to have to be connected. It's not just going to be separate numbers. So once again with this, it would be non-negative reals or non-negative rationals. Okay, so we're going to write either an interval or an inequality. We'll do both, but you have that option. Okay, now with this graph, similar to another one that we looked at, there's no end point like highlighted, but there is. It's just right here. That's a closed circle. We'll assume it's at 10. Okay, obviously we don't know for sure, but it looks like it's probably at 10. And then on this side, we have an arrow, so just keep that in mind. Okay, so as far as the domain goes, we're going to go, well, let's do the interval first. That might be the easier one to understand. So if you go all the way to the left and trace it down, it's 0. Remember, that means, so 0 years since it was planted just means when it was initially planted, like right at the very beginning. Now, if you go to the right, the thing is, there is no largest number. It's going to continue to go to the right. Yes, it's going up, but it's also going to the right. And domain is not talking about up and down, it's talking about left and right. So if you were to make a little number line of this, there would be a closed circle here at 0, and then the graph just keeps going to the right forever. That's it, there's no end. So it's going towards positive infinity. If the graph happened to be going backwards, then it would be going towards negative infinity. And if you're including negative infinity, you have to put that value first because nothing is smaller. When you're doing interval notation, the smaller value has to go first. Okay, so that's one way to write it. Okay, now some people like to write it as a sandwich even though there is an infinity in there. So if you wanted to, it would be 0, x, infinity. As long as the first number is smaller, they're going to be less than symbols. You never include infinity because you're not going to be able to reach out and grab it. So I'm not putting the equal to for that. But I am going to put the equal to for the 0. Okay, so you could write it like that if you wanted to. Or the easier inequality is just, imagine this was just a number line like we did during the inequalities unit. The smallest value is 0, and then it just goes, it gets bigger and bigger and bigger forever. So 0 is included and it's going to the right. So it would just be x is greater than or equal to 0. Now you might wonder how come the symbol here was less than or equal to. That's because if you look at them, they're written backwards, like they're written in reverse of each other. The one here, the x, was in the middle. So if you read it starting from the x, it does say x is greater than or equal to 0, which is the same as this. It's just that we put it on the left here just because it had to be like part of the sandwich, so to speak. Okay, again, I would do it like this, up to you. Okay, with the range, so we're going up and down. Okay, so the lowest that we go is this point. So it's the same point as before, but now we're looking at its y value. So we said that's probably 10. Okay, so small, lowest is here, and that's at 10. And then it goes up forever. So as it goes to the right, it's also going up, which makes sense because it's growing. Okay, so it's just 10 and above. So as far as writing it with the interval, it would be hard bracket 10 to infinity. Okay, we can do it as a sandwich. 10, y, infinity. Okay, infinity, again, never gets the equal to, but the 10 has a closed circle, so that will be included. Or very simply, you can just say, well, the bush is 10 inches and higher. So the bush's height is y is greater than or equal to 10. So when it's real world, it does make sense if you think about it. Okay. Now, this one, similar. It has an end point and an arrow, but it's not real world. Okay, it is a function. If you do the vertical line test, it works. Okay, you know it's a line that's not vertical. So, what color should I pick? I'll do blue. Okay, so it's function and relation. It's connected. So even though we don't know what the context is, it's going to be continuous. Okay, so now for the domain of this one, remember we're going left to right. So the leftmost point on this graph is right there. So that has an x value of -4, and it's a closed circle. Okay, so if you want, you can draw a little number line underneath. You don't have to. So then look for the rightmost point. Well, there is no rightmost point because there's an arrow. Yes, the arrow is going down, but as it goes down, it's also going to the right. So it's going to positive infinity. As far as left and right, it's going to the right forever, which means it's going to positive infinity for as far as the x's go. We're not talking about the y's right now. Okay, so if you were to draw a number line, it's going to go continuously to the right. Okay, so this is a little bit confusing because I know it's also going down. You have to try to separate the going across from the going up and down. So for this one, we can do hard bracket -4 to positive infinity. And you don't have to put the positive, by the way. You could just write infinity. Okay, or we can do -4, x in the middle, infinity on the right. They are both less than, but the -4 is included, so that has the equal to, whereas infinity never has an equal to. Okay, or quite simply, we can just say that the x is greater than or equal to -4, just like we did when we were writing the inequality based on a number line. So it's just x is greater than or equal to -4. Okay, this is one that you might need to look at again. Okay, this is definitely a little bit harder. Okay, the range. So now let me do a different color so you can see the difference. So for the range, remember we're going low to high. There's no low because there's an arrow going down. So it's just going to keep going down forever. So it's actually approaching negative infinity. Okay, and then for the highest point, there is a highest point. Oops, it's right here. So what's the y value of that? It's 2. Okay, so that's a closed circle. So the highest value is 2, and then it's just going down, 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 down to negative infinity. Okay? So here's the deal. Well, you can even write negative infinity if you want. With negative infinity, you do have to put the negative. I forgot here. I mean, again, you don't have to, but I'll just label this as going to infinity. Okay, so as far as the interval, this is wrong. A lot of kids are going to do this and wonder why it's wrong. This is wrong. The reason it's wrong is because for interval notation, the smaller quantity has to come first. So you can't put the 2 first if it's going down to negative infinity. Okay, so please double check yourself. I'm just going to erase that. So the smaller quantity is negative infinity. That goes first, and we're always soft around negative infinity. The highest is 2, and that's the hard bracket because it's closed. Okay, so notice this is like what I was saying above. Notice for the domain, the number on the left had the hard bracket. For the range, the number on the right has the hard bracket. It doesn't always have to be the same. Sometimes it is, but it might not be. Okay, if you wanted to write the sandwich, it would be negative infinity, y, and then 2 is the largest. So they both get less thans, and then the 2 is included, so that gets the equal to. And if the 2 had an open circle, then neither of them would have the equal to. Like, that's possible as well. Okay, or quite simply, you can just write y is less than or equal to 2. And if you notice, this matches this. Okay? And again, even this one matches this one. It's just that one of them is written backwards. So these are the same thing. They're just written in a different way. Okay. We're going to do one more, and then I'm going to give you time. Well, you're going to pause the video and do some practice. So this is the last one that we're going to do together. So as you can see, it's a line. It's not vertical, so it's going to be a function and a relation. It's connected, which means the domain is continuous, which means we cannot possibly list the domain and range. By the way, as an aside, sometimes on a line like this, some of the points might be emphasized, like there might actually be a dot at some of the points, and then kids think, oh, I'll just list those 3 points. So those points are just being emphasized, or maybe they were the points that were initially plotted, but those are not the only points on the graph. So don't let that fool you. The graph is the entire line, entire thing. So it's continuous. So you can't list. Okay, so as far as the domain goes, we're going left to right. Now notice, on the left, there's an arrow. On the right, there's an arrow. So although the graph is going up and down, it's also going to the left forever, and it's going to the right forever. So it's going from negative infinity to positive infinity. So when you have a line that it has to be a line that's on a slant, and it has arrows at the ends, its domain is going to be all real numbers. And in fact, so is its range. So it's really just the entire number line. That's why we say all real numbers, because it's everything. Okay, that's one way of writing it. You can write it as a sandwich. This one, I did use, they all use y for this example. I should have found ones that use something else, but. Okay, never include infinity, so you'd, oh, not y, I'm sorry, x. Okay, so you're not including it because it's infinity. Now, you can write all real numbers, or the fancy notation for all real numbers is this r with the 2 lines on the side. Okay, so again, you could also write it out and say all real numbers. Okay, this is because it's going left and right forever. Okay, now likewise with the range, the graph is going down forever and it's going up forever. So the range is also all real numbers. So I'm just going to copy this, but I do have to make one edit, and that's what I messed up before. This, if you're going to write it like this, you have to use a y for the range, or an f of x, or whatever the y variable is. Okay? Okay, so now I'm going to have you pause the video, but just to summarize what we talked about. So to determine if it's a function from a graph, you can just do the vertical line test. If it's a line that's not vertical, it's going to be a function. As far as discrete and continuous, a discrete domain is going to have disconnected points like this, like this. In that case, you just list the domain and range using braces. And by the way, I forgot to mention this, but you don't repeat the values. So like if you were to list the ordered pairs for this, each one would have an x value of -3, but you don't write it 3 times. You only write it once. Okay? And then for a continuous domain, regardless of whether or not there are arrows, the points are connected. Okay, it's like if you took a ruler and you connected the various points, that makes it continuous. Okay, so when it's continuous, you can't list because there's an infinite number of points. This is like real numbers, rational numbers, non-negative real numbers, non-negative rational numbers. They're not just whole numbers or just integers. There's too many. You can't list them. So in that case, it's either an interval or an inequality. Okay? When you're doing the interval, you have to put the smaller quantity first. Okay? Yeah, and just when you're doing domain, remember domain is left to right, range is low to high, and use the variables that are provided. Okay, so on the bottom of this page, there are 3 more graphs. So I didn't have room to put like this next to all of them, but you can just do it yourself. So state if each one is a function and a relation, or if it's just a relation. State if the domain is discrete or continuous, and then state its domain and range. So at this time, you should pause the video, do those 3 questions, and then when you're done, press play and compare to my answers. So go ahead and pause it. Okay, at this time, you should only be replaying it if you did it yourself. So these are the answers. So I used a different color for each graph to make it easier to see. Okay, so take your time, pause the screen so you can look at this and you can check everything over. And this is one of those things that a lot of kids, it doesn't click right away. It takes a while. You might not understand it right now. You might not understand it yet. But if you keep doing problems and you keep using the answers to kind of guide you, keep working at it, you will eventually get it. Thank you so much for watching the video. Have a wonderful day and good luck.